So hi guys, in this chapter we are going to see differential equations. It is very similar to uh, the integrals part that we did yesterday. So before going to differential equations, I would like all of you to go through the integrals part and then come back to this topic so that you can be very thorough with all the concepts of differential equations. So I have given you here all the important concepts just like usual, and then I have provided you with the identification models, various models, how to solve a differential equation, and then I have provided you with all the questions also. So if you guys have any doubts in all those questions or in any topic in general, you can feel free to contact me, and then I am ready to help you out, guys. I have provided my link in the description below, so feel free to contact me, and we will see more subsequent videos. Now it's time to get back into the session. So all the very best. So in this session, we are going to see differential equations. Before we get to differential equations, I want all of you guys to go through the integrals part that we did yesterday, because for most of the questions in differential equations, integrals will be coming, especially for the solutions and all. So I would like all of you to go through the integrals exercise, and then integrals video, and then come back to this so that you all can be very thorough with integrals, so that you will be able to adapt to this differential equations very easily. So now in this chapter, it is a very simple chapter. You have got some of the topics. First is representation of a differential equation. So I have given you two equations. So dy by dx minus cos x equal to 0. Mainly equation, everybody would be well aware of what is an equation, which has a left hand side and right hand side. So anything connected by a derivative in any one of the LHS or the RHS, so that is called a differential equation. So dy by dx minus cos x equal to 0, or d square y by dx square plus x dy by dx minus y equal to 0. So I am naming this as equation 1 and equation 2. So now we are going to see the next concept, that is order. So order, first of all, it is defined for all differential equations. So order means the highest order of derivative present in a differential equation. So that is the highest order. So if you see in equation 1, the highest order is 1, that is dy by dx. So order for this differential equation is 1, whereas for equation 2 the highest order is 2, so it is of second order. So the highest order is 2, so the order of this differential equation is 2. So that's what I have written. For equation 1 order is 1, and for equation 2 order is 2. The definition is highest order of derivative present in a differential equation. Now we go to the degree. Degree is nothing but the power of the highest order present in a differential equation that is free from radicals and fractions. So if there are any radicals and fractions, you will have to remove all those things, and then the power of the highest order present in a differential equation. And degree, for some of the equations it may not be defined, so that's what I have given. Degree is undefined, but order is defined for all differential equations. So degree is undefined for some cases, especially when the derivative is attached to a function containing logarithm, trigonometric or exponential. LTE, we already saw in integration. Highlight part, that same part I have written. L for logarithm, T for trigonometry, E for exponential. So when the derivative is connected to these terms, please understand, the derivative should be connected to these terms. If these three terms are present, or if any one of these, logarithm, trigonometry or exponential, if it is normally present in a differential equation without the connection of the derivatives, then the degree for such equations is defined. But when the derivative is connected to these three functions, that is logarithm, trigonometry or exponential, degree is not defined. Don't worry, I have given you an example also. So now we will see the examples. So for y triple dash, that is d cube y by dx cube. So that is called y triple dash plus y square plus e power y dash equal to 0. So now what did I tell you? Here, degree is undefined for some cases, especially when the derivative is connected to a function containing logarithm, trigonometry or exponential. Now here you can see that this derivative y dash is connected to exponential. So degree is not defined. But for us, for equation 1 and equation 2, which we have already written in the first page, dy by dx minus cos x equal to 0, order we have already seen it as 1. So the degree is the power of the highest order. Please remember, degree is the power of the highest order. Here you have got no powers. That means the power has to be 1. So the degree is 1 for this equation, dy by dx minus cos x equal to 0. And for this equation, order we have already seen it as 2, and the degree of the highest order. So again the degree is 1. So this is the concept of order and degree, and I hope that all of you would have been able to understand by this time. Now let us go to actually the solutions to a differential equation. These are very simple topics. There are 3 ways to solve a differential equation. First is variable separation method, another one is homogeneous, and another one is linear differential equation. So we will see one by one. Variable separation method, the name itself indicates you have to separate the variables. Suppose if the differential equation is like this, dy by dx equal to h of y, where h of y is a function of y, and g of x, where g of x is a function of x. So you need to group y variables separately and x variables separately and then integrate. So what we are doing, dy divided by h of y, we are grouping y terms to one side. Dy divided by h of y equal to g of x into dx. So now if we integrate this, dy divided by h of y, integral dy divided by h of y equal to integral g of x into dx. Now if we integrate this, we get the final answer. So this is nothing but variable separation method. It is a very simple topic. Now let us go to the next part, which is homogeneous. So homogeneous differential equation. First we will have to check. Suppose in the question if they ask you to check whether the given equation is homogeneous or not. So this is a condition for checking. So first an equation will be given where it is in functions of both x and y. So that's why I have written f of x comma y. You need to replace x by tx and y by ty. And if you do that, if it is of the form t power n into f of x comma y, where n is a whole number, suppose n becomes 0 here, and you get f of t comma tx comma ty equal to f of x comma y, then this equation is homogeneous equation. So this is the way to identify whether the equation is homogeneous or not. And now this is a way of checking whether the equation is homogeneous or not. If this condition is satisfied, then it has to be a homogeneous equation, and I have given you an identification how the homogeneous equation will look like. Like that I have given an identification. Y is equal to Vx. So either it will be of this form y by x, or either it will be of this form x by y. In your question, if you see y by x or x by y, then it is a typical homogeneous equation. This is how you will have to identify. So for y by x, I have taken a constant v and then I have cross multiplied so that y is equal to vx, or x by y I have taken again a constant v and then I have cross multiplied, so x is equal to vy. So these are the two models of homogeneous equation. So if this first model is applicable, then if you differentiate this dy by dx as per the product rule uv method, so you apply uv method here, you will be getting v plus x dv by dx. Similarly, if second model is applicable, then you differentiate this with respect to y. So dx by dy equal to v plus y dv by dy. And after that, you will have to proceed as per the variable separation method. So any one of these models will come and then proceed as per the variable separation method to get the final answer. So now next comes the linear differential equation. In linear differential equation, just like homogeneous, you have got two models. I have given you a special representation to identify this linear differential equation. So it will be of this form: dy by dx plus py equal to q, and here p is nothing but the coefficient of y. So after seeing this, you should identify that it is a linear differential equation and then proceed as per this. if is called integrating factor, which is nothing but e power integral p dx. So this if you will have to find out by integrating this and then using e power integral p dx, and after that, after finding out the integrating factor, you need to just substitute it in this equation. Y into if equal to integral q into if dx plus c. See, this is called a general solution. Suppose if they are asking you particular solution, they will be giving you the values of x and y. They will be giving you the values of x and y, and then you, after finding out the general solution, you need to substitute the values of x and y in that general solution, and then you need to find the value of C. So that is the difference between general solution and particular solution. A general solution will always have plus C, whereas in particular solution you will be finding out the value of C and then you will be substituting. So that is the difference. So now this is a one model of identification. I hope that all of you are clear with this model. The next model of identification is nothing but dx by dy plus px equal to q. Here p is a function of x and I mean coefficient of x. So integrating factor is e power integral p dy. So the solution is x into if equal to integral q into if dy plus c. So the same step you have to repeat. So it is very similar to the last question, last model. So with the repetition of the same steps, you get to know how to solve this question. Here also, if they ask you a particular solution, after finding out the general solution, you need to substitute the values of x and y, which is given, which would have been already given in the question. Find the value of c and substitute it back again. So with this differential equation topic is over, and I have given you the numericals. See, all these numericals are taken from the new edition of the textbook. Please remember, it is not the old edition. Old edition may have deleted syllabus. So all these questions are taken from the new edition. So please don't confuse yourself. Please refer to the new edition textbook. So 9.1, 9.2, 9.3, 9.4, 9.5, both the examples and the exercises, everything is being given. So if you want any clarifications from differential equations or any one of the chapters, you can feel free to book a session with me. I have given you my WhatsApp number in the description. So feel free to contact me and we will see very interesting and subsequent videos in the future. So all the very best, guys.